Hello everyone, welcome to my new project. I'm very happy to complete my this project because when I started learning ML from beginning, I wanted to make this project. So this is my farmer suicide predictor, or we can say distress predictor. So my problem statement was like uh, the farmers from childhood. I have been seeing that the farmers are suiciding every year, every like in Maharashtra itself, there are more than 50,000 cases of suiciding from past year. So we know that the 12 farmers every day do suicide. So it was a project which can be implemented in government, and government bodies can use something like this, not this, but something like this to their governance. So they can calculate the distress of farmers, the average of that area, and then they can implement some schemes like loan waivers and helping farmers and something like subsidy. So let's start and walk through my project. Okay, so this is my project or code. Let me kill the terminal. Okay. Okay, so this is my train model P1. So this is for training a model, and this is for front end, and I'm using Streamlit for front end. And you can see this. These are the libraries. So I'm gonna explain this project top to bottom, and I'm explaining like even if you are new to ML or you don't know any ML, you will get a brief idea at how things are being used or implemented. So let's start from the beginning. So this is my train model pi, and this is my app pi. So what is it doing? It's making another file, which is farmer data model dot joblib, and then it's storing it in another file, which I have extension of joblib. It's like binary or machine readable code, and that's the brain of our main model. So I'm using some libraries like Panda, NumPy, Sklearn. So let's know about this. So pandas. So these are used for data manipulation or something like this. Or we can say that it make a spreadsheet or Excel like tables from your context. This is for NumPy. So this is a math tool module, or we can say we can operate on numbers or arrays on this module. On this, the sklearn. So this is the main machine learning toolbox, and these are giving us some features like train, split, and crossfire score. So what this do? So this split our data into some section so we can study on that data and test it. And okay, so this is the standard scaler and one hot encoder. So what this do? This clean our data. So it's easy for removing the garbage data or garbage values or the data which is not important and all. So this is column transformer and pipeline. So this is for organizing our data. Okay, so you will see where I'm implementing this. And after this, you can see the main our structure of brain, the XGB classifier. And I'm importing this feature from the XGB module. And then this is the job lib. You will learn what is this. This is a warning for warnings and all. So okay, so let's start. So this is seed. So this is for 42 is our seed for generating the random values. Okay, so you will know why I'm generating random values further. Okay, so let's come here. So this is our data templates. So this is our district data. You can see there are 36 districts of Maharashtra. This is our crop list. I have taken the most uh, planted crop list in Maharashtra, and this is our estimated prices. These are prices I have taken from 2025. So these are the wholesale prices where the farmers sold to mass buyer. And this is our templates. You can see these values I have taken from my research, and this is the templates you can see. And from here you can see these are in samples. So my sample size is 50,000. I can make is sorry, it's 5,000. I can make it 50,000, but it take me so much time. That's why I'm taking it 50,000. But the much sample you have, it's better to train your data on larger sample. But currently I'm taking a 5,000 samples. And okay, this is our loop where it's taking this n samples and making a random, you can say, simulated farmers and making its code, we can say a data, because it's very hard to generate the 5,000 data and fetching it manually. So that's why I'm generating a random data, but that random data is based on average, which I have researched. So you can see here. So this is my 5,000. This is for making my 5,000 sample size. Okay, so you can come here. Okay, so this is NP random gamma and this is NP random normal. So we can say that's the NP random gamma. So this is for screwed like data and the NP random normal, which is here. This is for a bell curve like data. Okay, so this is what you should know. Let's come down here. This is the farmer's data list for appending. Okay, let's see this. This is the PD data frame. We can say this take 5,000 sample size of farmers and then turn it into a big spreadsheet, or we can say a data frame, to make and calculate all the things and apply algorithms where you will see further. So this is our DF, debt to income ratio. So this is we can say string like uh, array of strings, you can say. So I'm like you can see I'm calculating debt to income ratio by debt amount divided by total calculated income, where I'm calculating the income like I have a spreadsheet, or I think I should say I have data of estimated price list, as you would have seen upward. Uh, okay, so I'm calculating the total calculation income from there. So I'm estimating that the total calculated income is the annual income of farmer. Okay, so let's go further. Should okay. Okay, I should tell you this. So this is risk status, and you can see how I'm calculating it. So I'm calculating and I'm taking the random samples from my 5,000 samples and checking if what is the risk probability of farmer. I'm calculating the risk score here. So I'm seeing if the probability is lesser from compared to the sample, I'm increasing the risk status, and if it's less, I'm decreasing the risk status. So that's how I'm calculating the risk status. Okay, so let's go here and we can see this is our first axis. We can say question axis. This is our answer axis where we are pasting our including the answers. So this is x-axis and this is y-axis. Okay, so let's go. Or we can say this x-axis is what it's doing. It's including our all 16 features, or we can say bases, where we are calculating the risk, and then it's comparing with the answers, or we can say our sample size, where are the answers already predicted. Okay, so let's go downward, and Okay, so this is our classifier and this is our preprocessor. So what preprocessor is doing? You can see we are using caller transformer here, and this have standard scaler and one hot encoder. So what it's doing, the XGB classifier is smart, but it's not that smart that it can learn or which knows the text format. So it's converting our text format into numerical features, and then it is learning all the things that we are talking. So like we can say this is standard scaler. So what this do? Like it scale or give the importance to every value. Like this can think that the depth is more important than drought because depth can be lakhs to crores and the drought month can be only 0 to 12. But the if drought is around or more than 6 months, then we know that the depth amount will not be considered or will not be that much important, and we can guess the outsource or we can say the result based on only drought column. Okay, so this is what it does, and this is one hot encoder. So what this do? This take our 36 districts and make the columns like with one, and then let's come down and I'll show you the model. Okay, so this is our model. So this is the main brain where we are training our model. This is our pipeline. So what type pipeline does? Like we can call it, visualize it as a array or we can say queue. For simplification, let's consider it as a school's assembly line. What it does that the first data which came, it cleans it, and then after cleaning it, it send it to the classifier to get predicted, and then after comes the second data. So this is our pipeline. Okay, so let's come. Okay, so this is our magic command, or we can say where the all magic happens. So here is where the X train and Y train are fitted, or we can say trained. So we can say that it fit the pipeline to our assembly line and using the training data like on the Y train and comparing it to the X train where the all 1000 the results are stored. So if you are thinking about where the 1000 results are coming, so this X train have 4000 results and this Y train have 1000 results. This X train are based and choose from random sample size where you can see here we have taken okay, so this is our 5000 sample size. So 4000 is in x axis, x, and 1000 is for prediction and teaching our model. Okay, so come down here again. Where was we? Where we? Okay, we were here. So this is where the training is completed. Okay, so after that, we should go to pipeline. Okay, so this is our YPRED, the pipeline predict extract, and this is our Ypred probability, where the probability is predicted. So this is where the probability and all are calculated. And we have classification report here. So it print the classification report from low risk to high risk. So we can compare. And it's like a report card, or we can say accuracy measures, which will be calculated on AUC score, or we can say ROC AUC score. So RUC, I forgot the full form, but it was something like area under receiver or operating character curve, something like this. So this is the thing, and it will be something like or close to 95% to 90%, but if it's around 50% or if it's more than 100, I think it won't go above 100, but if it correct 100, or we can say in probability basis, if it's basis, it is 1 to, sorry, 0 to 1. But if it is completely one, it is called the overfitting. And if it is below the 50% or below the 70%, it should be called the underfitting. Let me show you on the graph so you can visualize it. Okay, so this is our graph. Okay, and these are our data. Okay, so what happens if we have line like this? You can see the error percentage. So this is p minus y, 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 this is p plus y, this is p plus y. So this is all the error, and this is very much error, and it will be, so there will not be any difference between the normal data and the outliers, which are in the outside of the box. So this is what underfitting means. And let me show you what overfitting means. So, okay, so let's consider this is our data and this is our model. So have you noticed how this have around or completely 100% accuracy. So this is called overfitting. So if you do and give any other data to predict, it will completely neglect that data and predict on basis of this data. So this is called overfitting. So our table shouldn't be overfitting or shouldn't be underfitting. Our table should be somewhere mid around it. Okay, so this was the basic concept in ML. So let's close it. Okay, don't say. And come here. Okay, so where were you? We were here. Okay, so okay, let's come down. Okay, this is our model data. Here is our pipeline. This is our districts, crops, numerical features, and categorical features. And this is where job lib is dumped. Okay, so what is this dumped? So this is, we can call it a save button where we can save our model data to a model file name. And you will ask, what is this file name? So this is farmer.risk.model.job.lib that I was telling you. That's why we are using job lib. So what it's doing, so it's creating a spreadsheet-like structure using assembly or machine readable formatted files, and then it's making a file which will have the trained model. Okay, so let me directly show you. So let's open it. And when I will run our model, first let me save. Okay, let me run our model in Python. Okay, so here you can see, you can completely see here our 4.0 version. We are loaded. Okay, this is our classification report. This is our F1 score. Okay, this is our support, recall, precision. This is for low risk. This is for high risk. Okay, this is for average and weighted average. And this is our confusion matrix. This is for actual low and actual high. Okay, so this is our score, which is 71, and which is not too bad because our sample size is not very variant and not very big. Okay, so when I was using 50,000 sample size, it was coming around 92, 0.92 something. Okay, so this is our, you can say, risk factors where I have told you that it will tell our model is dumb or not. So here you can see our previous crop failure. This has more value, and the districts. So based on district, have this less value, and that interest rate have less value. And you can see here these have more value because previous year this districts what we say suicide rate was most, you can say, the most of the importance have to crop failure, access token irrigation, and the share of informal debt. As I told you, it's the third party debt. Okay, so I think on basis of this, I can tell that our model training has been good and our model is smart, because if it would have considered this up here, then I would say that our model is dumb. Okay, so it's uh we can say saved. You can see here is a file created now. This is our application, which is being for front end. Okay, so let me save it. And this is not that important. I am using somewhere CSS for internal and integrated CSS for style. And here is our model is being catch and stored. This is the main code where our model is storing and calculating and displaying here. And see here we are using a SHAP numpy and the Streamlit for front end. Okay, so let me run it again. Okay, so as you see, we have trained our model again. And let me run our front end. Streamlit run dot py. And hey, you can see your model is working. Okay, so here you can add the values to predict. So let's start. So consider that we are in Pune. The loan giver is active. The previous Pune suicide rate is very less. Okay, so it's like 13. And then in finance, okay, we have 1.5. And in Pune, the third party money lender are not that much. So here we can say the average interest rate, if we are taking from government, right, okay, around 9. And income is stable. The family size is, let's say, 5. The farmer have around 5 to 8 acre lands. Okay. Irrigation, they have irrigation. So market in Pune is average around 10 kilometers. We have everywhere the market. And in Pune, mostly people are okay. So rice is mostly used. So average farmer, which have around 100 bags. So 100 into 50. So let's we consider that as a okay. You think the 50,000 kg is enough and no previous crop failure. The climate change and climate. The 800 is 800 rainfall is okay. The drought months are not that much. Okay, so the temperature, okay, let's keep it like this. And if we are calculating, you can see the risk assessment of suicide or the distress is very less. You can see the 3.6%. Low risk, very low. So we will call it a happy farmer, I guess. Or let's we talk about something else or someone else farmer. and take a new farmer. Okay, let me go. So most of the suicide rate is in bid. Okay, loan viewer this year has not been assigned around 18. Okay, the fine in bid type there are still a Saukari system going. So let's consider the 50% is, and the average rate will be then even if he's taking the interest from government bank, after including the interest rate from the third party, it will be average of around 20%. Okay, and the income status is very unstable. Family size, let's keep it 5. And crop, the most of the crop is taken is it's called bajra. We can take multiple crops, but I'm taking jawar. Let's say 1,000 kg is too much. Sorry, too less. So let's take 5,000 and can take here yes, previous year. The rainfall, there is very less rainfall, like 500 millimeter, and drought months are usually 4 months there. And temperature, let's keep it like this. You can take it, you can check it. The mode, it's moderate, okay, and still it's a low risk because it's based on every person's point of view. So you can see still the risk factor is very high, and you can see the recommendation: continue regular monitoring, encourage participation in farmer welfare. There are some specific recommendations and actions, and you can change the prices of crop here. The sugarcane's price is in ton, so don't change it too much. Okay, so as you can see here, this is the income breakdown. Okay, so you won't believe the normal farmer's income in Bid area or Vidarbh area is nearly 2 lakhs to 3 lakhs. So that's why they have to migrate from their hometown to somewhere else. So thank you for watching my project and staying till end. I'll meet you with another project. Thank you all.